Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion is part 21 of an ongoing series talking about Operating System Deployment in Configuration Manager 2012. Today's session will focus on troubleshooting. So as we've gone through the series to this point, we have touched on troubleshooting, seen the logs a couple of times. We're actually really not going to see the logs today, not in any great extent anyway, but do want to focus on a few troubleshooting items. So here's the agenda. So first of all, in order to really do effective troubleshooting, we really need to understand where, or the task sequence flow and associated logs, where they are in each part of the flow and so on. So we'll start there. Then we'll talk about how we go about customizing task sequence logging, why we want to do that, how we go about capturing logs in the event of a task sequence failure, some interesting things around that. Then we'll quickly hit on task sequence progress, tracking it remotely, how we can track progress in Windows PE, talk about just briefly a few additional logging points, and then we'll be done. So in terms of understanding task sequence flow, I've got a little diagram here that we'll start. And so there really are three major phases of imaging, right? So task sequencing related to imaging. You may or may not hit all three of these. Phase one is where we are initiating the task sequence, the imaging, from within an existing operating system. So that would be a re-image type scenario, an upgrade type scenario. You may not be doing that. If you're in bare metal, you will not have phase one as shown here. You'll just have to kind of move phase one down to the next phase and so on. If you do initiate, though, in phase one in the existing OS, then it's interesting to note where the logs are. So we'll trace the logs through each section, and so when you're kicking off in an existing OS, the logs will be in the same location as all the rest of the client logs, CCM logs. And the logging level, so we'll talk about verbose logging in just a minute, the logging level will be whatever you've configured for the system, right, in that case. So once you get done with phase one, and shouldn't take that long, do some state capture maybe and different things, and then we'll reboot into Windows PE. So probably the last thing you'll do in phase one is specify a reboot step and specify to reboot into Windows PE. That will cause Windows PE to be downloaded to the local hard drive, the boot files adjusted, and then there will be a reboot. So once we get the reboot, will boot back up into Windows PE. So that, by definition, will load into RAM. The hard disk will no longer be one that we care to preserve, because in imaging, we're going to essentially erase the hard drive in many cases. So we'll move log location. So one of the first things you're going to do in the PE phase is a format and partition. Before you do that, then you're going to find all logging to be in this directory, right? After you do the format and partition, then you'll quickly see this location contain the log files, and then finally we'll end up with the formatted disk location down here with the underscore SMS task sequence logs SMSTS log folder, right? So 4 moves of logs just in that little short bit of time. So as we finish up the PE phase, that's after the image is applied, drivers are downloaded and applied generally, and maybe software updates are done, a few other things, we'll get another reboot. Right? Now, if you look at the task sequence, it's very clear where the reboot is from phase 1 to phase 2. It's not so clear where the reboot is from phase 2 to phase 3. It's one of the first things I'll ask, I asked it earlier in this session, I'm quite certain, is where does the reboot happen from phase 2 to phase 3? And the answer is there's actually a step, you can go look in your task sequence, called Configure Windows in ConfigMgr. That is a step that does cause the reboot from phase 2 to 3. It doesn't show as rebooting, but it does do the reboot, right? It's embedded in that step. So as we process that step, part of it starts in phase 2, it finishes in phase 3. Once we reboot, now we're in the new operating system that has been laid down. Our log location here is the same as it was up here, all right? And it stays that way until the ConfigMgr agent is installed. The ConfigMgr agent will be installed very quickly, because the step that installs the ConfigMgr agent was responsible for the reboot and finishes up first. Once the agent is present, then we'll actually have a new log directory, right? And then after the task sequence is completed, we'll have the standard logs, right? So obviously, the logs move around a lot. If you're wanting to troubleshoot, which is what we're kind of talking about here, being able to follow those logs is important. And so you can either decide to track them manually, or you might want a more automated way to track where the log is. Why would I want a more automated way? Well, hang on, I'll show you that in a minute. But nevertheless, there is an embedded, if you do want to use a more dynamic way of tracking where the logs are, because it could be that different material is in different logs at different places, and if a failure happens along the way, you might want to know where you were at that moment in the logging and be able to go right there. There is a variable that's built into the task sequence engine called SMSTS log path, and every step of the way it will keep track of where the logs are located, and you can tap into it and do different things based on that, right? So these are the phases of imaging, and knowing these phases are important. All right, now let's talk about customizing task sequence logging. How do we actually do it, right? We talked about the three phases. We'll talk about how we customize the logging in those three phases here shortly. Question is, though, to start this discussion, why would we want to customize task sequence logging? Isn't what we get in task sequence default logging good enough? The answer is largely, yeah, it is, right? But there could be some reasons, and a few of them. One of the things that is very useful to do in just configuration manager logging in general, but certainly in task sequence logging too, is increase the size or the history count of the log files. So the way the logs work, pretty self-explanatory, or pretty well known, is as we log to a file, we will fill up that file, and as we do, we'll rename that or move that to the historical log, the LO underscore equivalent of that log, and we'll keep on logging until we fill everything up, and then we'll just start dumping data out of the historical log. So the point is, eventually you're going to lose data that might be relevant. Well, depending on how much is going on and how fast logs are moving and so on, you might lose relevant data to troubleshooting pretty quickly. And that, again, is not just a task sequence logging statement. It's a generic logging statement. So it could be that in order to preserve logging history long enough to be able to sift back and track a problem that you found, it is a good idea to either increase the size of logging or have historical logs. And it's really no harm, no foul to do either. The only downside in my mind of having larger logs is it takes longer to load them, right? So in some cases, and in fact, in Microsoft, we have historical logs in excess of the default of 2. For that reason, they just kind of spool up so that troubleshooting information is available. Another reason that you might want to adjust logging is to increase verbosity. So we do a really good job in the task sequence environment, and certainly logging in general, of writing detailed logs. But you can get more detail if you need it, and sometimes it's beneficial during the process. You can increase log verbosity. You can do that on the client just without task sequencing. You can also do it in the task sequencing environment, right? So we'll talk more about that. All right, so then the question is, where do you customize, right? What options are there for customization? And the answer is there's 3 phases of imaging. So there's 3 phases where we might want to do customization, right? There's in the original operating system, in Windows PE, and in the new operating system, okay? So I'm just going to hit all 3 of those. I'm going to pull the lab in real quick, and I'm going to hit all 3 of those and talk about the choices that we have in each. So this is just one of my primary sites, all right? And for sake of this point, I'm just going to go to a command prompt. So in phase 1, which is the portion of imaging that happens in the pre-existing operating system, there really are 5 options for logging. And I'm going to show you the command line version. So one point to make. When you install the ConfigMgr client, you have an option at that moment to enable additional detail around logging, right? And I think it's a very good thing to do in general to adjust the logging. Now you don't you're not stuck. If you don't do it at client install, you're not stuck. You can do the same thing manually. I'll show that to you in a minute. But let's just say we have CCM setup, right? There are a few options. First, we have CCM debug logging, right? Actually, let me start with this one. CCM log enabled, or enable logging. Right? So this is going to determine whether we turn logging on or off. Well, logging is on by default, so not a big deal, unless you want to turn it off. Not sure why you'd want to do that, but you can. Once you have logging turned on, there's a couple of other options that you might want to factor in. First is CCM log level. So, and I'm not setting these, but I'm just showing the command line switches that you can use here. CCM log level works actually opposite of the way you would think it would, that normal settings work. So typically, a 1 means verbose or on or something like that. In CCM log level case, 1 is the standard level of logging. A 0 means the most verbose level of logging. And so if you want to increase logging verbosity, it would be 0 here. And then there's an additional level of logging that you can set up called debug logging. And that is not on by default, but if you do, it throws additional detail in the log. Oftentimes that's not necessarily useful unless you're working with someone from Microsoft, but there are certain things that won't log unless you have both log level 0 and debug logging turned on, things that you want to see, specifically management point logs and so on, location services logs and so on the client won't write the kind of detail you want to see if you're in a troubleshooting scenario. So a couple more options that we can then specify. So CCM log max history allows you to specify how many historical logs to keep. And then the last one, CCM log max size. All right, and that will let you specify how big you want your logs to be before they roll over. So all of these completely open to you and what you need. And like I say, if you don't specify these, and most environments don't, take caps lock off now, this is not something that you have to reinstall the client to turn on. If you go in to the registry and just go under Microsoft CCM, right, and then scroll down, there's the logging key. And under logging, there's this thing called @global. Well, if you look up here at the list, the only one that is not listed here is debug logging. The rest of them are listed here and set to the default values. You can come in here and change these on the fly, and then that will kick in immediately. Right? Debug logging is enabled by going down here under logging and creating a new key called debug logging. Right? There's nothing that has to be in that key. It just has to be there. Right? And then now you've got all 5 options for logging. You can specify in the registry. You can turn those on if you want on the fly, turn them off on the fly, whatever you like. Right? Now, just to specify, this is not, again, task sequence specific logging. This is general client logging because, and it works in the task sequence because while you're in the running OS, all of the client processes inherit the logging values that are part of that client. Right? So in phase 1, this is how we cover the additional logging. All right, well, what about phase 2? So in phase 2, we are in Windows PE. So this is the Windows PE phase of logging. And unfortunately, it would be nice if it did, but unfortunately, we do not carry those log settings forward from the system we just came from, the original OS, to the client. Right? And in some cases, I mean, even if we did, it wouldn't matter in the case of bare metal because you're not starting within an existing client. So there is a need, if you want additional levels of logging, to configure that in Windows PE. So how do you do that? Well, it's actually not hard. There's 2 ways. So I'm going to show you the more automated way, the way that I find more preferable. And then you can actually do this differently than what I'm going to show you by opening up the Windows PE image, boot image, and so on, and injecting some of this stuff yourself. But this is the easier way in my mind, and the more supportable way and sustainable way. All right, so the first thing you need to do is create a file. The file is called smsts.ini. So I'm going to go find it. In my environment, that's going to be under OSD bin and then I have the x86 and the x64 boot images. Okay, so here's a point. These are your default boot images. If you want to increase the logging on a custom boot image, then you're going to have to go to those custom boot images and make the changes I'm going to show you. Right? But in here, so if you scroll down, you will find, or you will see in my case, there's this file. Okay. Now, if you go look in your environment, that file is likely not there. This is a custom file you have to add. You can create it wherever you want. In Notepad probably is the best place to do it, or a similar text editor. Save it as smsts.ini, not smsts.ini.text, which can happen sometimes. And once you have it created, move it to the folder that contains the boot image you want to modify. In this case, I'm going to put it, or I have put it, in both the x86 and the x64 version of the boot image, the files here. Inside this file is just a very simple section to define logging. So you see I have these exact same options that I just showed you, the CCM log level, CCM log max size. The only difference is in this case there is no CCM ahead of it. The name takes away, in this case, the CCM. Wish it was consistent. It's not. Not a big deal, but potentially a little bit confusing, right? And you set the values to what you want them to be in this case. So in this case, I've configured to the most verbose I can. Here's the log size I want to go with instead of the default. I don't think that's the default. 3 historical logs, and I have enabled debug logging. Right. The only one that I don't have here is log size, or wherever it is, log level, whatever, I can't remember. There's one. I'm not seeing it, it's not clicking right now, but I have 4 of the 5 here. Sorry. Enable logging. Sorry, I just had to see that. So enable logging is not there because logging is enabled by default. All right. So now that I have that saved, so again, you can create this externally. You save it in here, put it in here, right? Then I have to go and modify a different file. So these are OSD specific boot images, so that's why they're under the OSD node. Next, where I want to go is back to the root and into binaries and into x64. And if I just simply type OSD, then I'm going to find a file called OSD injection. It's right here. This file will be here by default. So what this file does is an XML file. I just open it in Notepad. This simply defines the files that you're going to inject into a boot image when it's created, into your PE image when it's created and so on, right? So if you're familiar with reading XML, the key stuff starts around here, right? So I'm just going to highlight and carry it down to architecture, the next instance of architecture I see. Come on down. There's a little bit of detail in here. I think I've passed it. Let's see. Here, I'll just search for it. That's probably easier. And search up. Oh, I did not make it far enough. Okay, good enough. Search down. There. Okay. So my point in showing you this, so whenever you look at our documentation, it asks you to look for this block of text. Well, this block of text can be potentially confusing because it will say, look for this block of text which has x64 in it, and then add this section which I've already added that has i386 in it, which seems to be in conflict. It's not in conflict. Again, if you're familiar with reading XML, we'll just highlight this block. Notice the / architecture, go all the way to the top. Takes a second to scroll, go on up. Okay, good enough. And you'll see this is where that architecture section started. So we're actually defining the details for the i386 architecture. It's just the addition that we're putting in is at the end of that section, so it's easiest to say search for this because right above it is where we're going to make the addition. So just to clear up any potential confusion around that. But this is the section that you add. So it's simply telling in the definition, add the file smsts.ini, which I just created, and its location is in the bin i386 folder, and whenever you add it, put it in the Windows folder of the resulting boot image. So the point is, whenever you load the boot image, the Windows folder will contain smsts.ini, right? And the fact that smsts.ini is there will cause the logging to begin in the level you specify, right? So just like you have the entry for i386, if you let me scroll down again. So here's the next section. So there is an IA64, which is interesting because we don't have any boot images that are IA64, but there it is, right? So search for it again. Here's that other section that you want to add if you're going to support the x64 boot image too, right? And put it in here. Okay, same exact section. The only difference is I'm telling it the location to grab it is bin x64. Okay, so that tells the wizard, the engine, to go add that file whenever the boot image is created. All right, so that done, all that needs to happen now is to go in and create task sequence media. In this case, I would just choose bootable media. I've worked through this wizard many times, so I won't work through it again. But watch the process go forward. The boot image is created. At the end of it, I have an ISO file. So I've got that ISO file, and I've actually attached it to this machine. And here it is. So this one is this one is boot verbose. And so I'm going to go ahead and open up this machine, start. And we'll see whenever it loads up that it has that smsts.ini in the Windows folder. All right, we can even hit the F8 now and look. Okay, and there it is. And so there's the detail. All right, so if I just click forward and tell it to run just the standard, yeah, I'll just tell it to run that one. Hopefully it'll kick off and work. All right, let me just, all right, so let me, okay. Let me see if I can find it. So let's see. All right, so you see, let me keep searching, see if I find any more entries. Now I don't. So, but you see, let me see if I can find SMS. There I'm referencing those things. See if I can find that yet. I don't want to go through a full imaging process, but there we go. Yeah, used smsts.ini to set the log setting. So that only happens because we found it, right? And then we absorb the log settings from there, right? And that's enough, right? But that makes the point. All right. So then the question is, that's phase 2, right? We're done with phase 2. So then we move over to phase 3. So where do we actually go add the logging for phase 3? Well, phase 3, we're back inside a running OS, the one we just deployed. So in this case, to add the log level we want to finish up the sequence and even to put on the client, we just go back and put the command line properties here, the CCM log level, CCM max log history, all that. We put that on the command line, so whenever the client's installed, it inherits those. Now, you might be in a scenario, hopefully not, but where you want to put on verbose logging while the imaging is done, and then take it away once the imaging is finished. Well, you could do that if you want to. I could envision just using the command line here to set up your verbose debug, max logging, whatever, and then let it finish up through the task sequence, and then at the very last of the task sequence, use some registry edits to set it back to what you want it to be. It seems like a kind of a strange scenario to try to set it one way and back another and so on. Logging is not that big of a deal. Even increasing the verbosity of logging and the number of logs on the vast majority of modern systems, any modern system, I can't imagine it being a big deal. Right? All right, so that is how we set up verbose logging. Those are the different phases of imaging, and so on. All right, so knowing the logging and so on, knowing that we can do that, what the logs are, that we can get to the logs and have control over them. The logs are really good. They're sectioned and phases and different things. How do we go about capturing logging from a failed task sequence, right? So maybe you're imaging 150, 200 machines, maybe more at a time in a build center, whatever, and you want to make sure that you don't miss logs in case there's a failure, right? How do you do that? Well, a very common practice is to simply enable the F8 command prompt on the boot media, on the boot image. Certainly doable. But if you look at the properties of any boot image and look at that checkbox to enable the command prompt, you'll see right there it is not recommended for production use. Why? Because if you have F8 access, you have full unfettered control to get to the hard drive of the machine that either you're imaging over and replacing or the new image you're laying down, right? It's just a risk. I mean, you can be the judge of how much risk it is. It's a very common thing that environments use F8 even in production, but it's not recommended, and it's really not necessary to do that in production, right? The reason that people want F8 control in production largely is to be able to intercept and get logs and work within that system if there's a problem and so on. I get it, right? Weigh the decision, is that worth it compared to the risk that you just incur by doing something like that? Is it a massive risk? Have I ever heard of a problem because someone used F8 to inject malware? No, I haven't. I don't know if it, will happen. It could happen tomorrow. Don't know, right? It's just something for you to assess. The reason I don't think it's necessary is because if you engineer your task sequence in a way that handles the errors should they pop up, then the task sequence itself can handle the copying of the logs out to a location so they're preserved and you don't have to worry about it, right? There's actually two ways to do task sequence error handling. Well, two ways that I'll talk about here. One is a fully custom way that you build yourself into the task sequence, right? Another way is to simply leverage the MDT wizard to create your task sequence and see what it does to create the section for error handling, and it does create one, right? Let's look at both. We're going to start with custom. This is a blog that I found that actually goes through a pretty good write-up of how to do it. I'll show it to you, largely following what is in that blog, because this is the way I've done it for as long as I've done it, right? All right, so this, if I go into my lab here, a little bit of a different lab, I have 3 task sequences. One is just a standard old task sequence. Let's look at it. This is the most basic task sequence that you probably will want, just to lay down the image, load the client, reboot into the new operating system, and we're done. Right? Very basic. So so very basic. Now, if what do I do to that task sequence if I want to add error handling capability to it? So should there be an error, what do I do? Well, this is the version of that same task sequence created to handle errors, right? So to understand this, let me call attention back to what we talked about early on in the series, and that is the flow of the task sequence. It's one of the very first things I always talk about whenever I talk about task sequencing and OSD, or the task sequence engine. How does the flow of this work? Because knowing how the flow of this works is going to be pivotal to understanding how error handling is possible to implement and so on. And so I always start asking the question, okay, the task sequence starts up here. What's the next place it goes? And people say it's here. And then I'll say, okay, great, where's next? And they'll say here and here and here. Then we keep going and they get bored. I'm finally down here and I say, okay, what's the next step? And they yawn and say, okay, it's here. And that's when I say, no, that's not right. Right? And I make the point. Because the way this works is within a group, we get down to the last section, assuming no errors, and we complete it. We hand control back up to this group and then decide, is there anything else to do that is in line? Then we go back down here, do this step, hand control back up here, find out is there anything down below that I need to do. The answer is no, there's nothing else. So I need to hand control back up here to my parent and then see if there's anything else to do. I would hand control back here, right? That's the flow of it. So when you inject error handling into your task sequence, there's a couple of things you want. One is you don't want the task sequence to fail in the event of an error. You want the task sequence to continue on, collect your error handling, maybe notify you of a failure, but at least collect your error handling and finish up. 2, you don't want the task sequence to enter the error handling section unless there's truly an error. So how do we handle that? Well, let's just pick a couple of steps. Let's look at the task sequence. Every single task sequence step by default is set to not continue on error, which means that if there's a problem, it just fails. It doesn't really fail in this place. It really doesn't, right? It's going to follow the normal flow and hand control back up here because you can't continue, but yet you're not just going to bail at this stage. There's something, you're in an embedded group, so you hand control back up here and check. This is not set to continue on error either, and so we would hand control back up here. And in this case, I do actually want the task sequence to continue, so I have manually chosen to have this main group continue on error. So that means no matter where I fail here, again, none of these are set to continue on error, right? They're all blank or all set to fail. If there's a problem, we want to stop the task sequence. So, but I don't want to stop the task sequence to the point that I can't collect my logs. So whenever there's a problem, say here or anywhere in here, we're going to set a variable inside the task sequencing environment, you'll see it in a minute, to indicate there's an error. And then we're going to begin the processing to see if there's anything else we can do. Normally, we would just pass control up here, and we would see continue on error is not selected. And so we would pass on down here, and continue on error would not be selected there, and we would exit. It's not what we want. We do want to continue. Sorry, that's not true. We would bail out because we would never get down here. But in this case, we do want to continue on error and hand control down here. But what we don't want is for this group to be processed if there is no failure, right? So let's just assume that this image works successfully. It goes all the way through. We get down here. We're going to hand control back up here, hand control back up here. There is no error. And so we are always going to come down to this group. Regardless, we are always going to get down to the error handling step, whether there's a failure, whether there's not. If there is no failure, we do not want to process this group. How do we handle that? We actually use a variable. It's an internal system variable called SMSTS last action succeeded equals false, and set it to false. If there was a failure, this will be false. If there was no failure, it's true. If it's true, we just pass right on and we exit. We don't do anything in this group. But if there's a failure, we're going to continue on and do these steps. And so these are very basic. You could actually add a number of things to it. You could call out and send an email. You could hook into Orchestrator, as we've shown. You could do whatever, right, you want in the error handling. What we need to do, though, at the very minimum, is get those logs moved from the imaging system up to a network share or some other place to preserve them for troubleshooting, right? So the first thing, I'm just going to map a drive to a known location and then check. So this is using, this step will use another internal variable called SMSTS machine name. Depending on where the failure happened, that machine name variable could be set to the real ultimate machine name, could be set to mini-int, whatever, but we're going to first check that share location that was specified on the L drive to see if there's a folder that exists with the name of the machine that's imaging right now. And if it does exist, I'm going to remove it. Then create it again, same variable, and then here we're going to leverage just a copy. So this is the log path, that SMSTS log path variable I showed you to track where the logs are, because you want to get them from the current location where the error happened, and just copy them up to the drive, the map drive that we just created, or the share folder that we just created. And that's it. That's the minimum, right, that you want to do. And it's very easy to do. So one of the things that a couple of questions that I've had whenever I've seen or whenever I've talked about this before is one, okay, what do you do if there is no ability to access the network, right? Well, you can actually build logic into these steps to say if there's no network access, if you can't successfully ping a server, you can manipulate the continue on error steps and so on to make sure this responds the way you want it to. But if you can't connect to a network share, if it fails, then just simply identify a drive locally on the machine that you can copy the logs to, because the thing you want to do is preserve the logs, even if you can't get to them by simply navigating to an Explorer window. Maybe you have to boot the system again in PE. At least you can get to the logs if they're preserved, versus having the system maybe get into a loop and start trying to image again and wipe out the logs, and now you have to wait and so on, right? So there's ways to do that. The other question is, can't you just put all of this into a script? The answer is yes, and that's how MDT works, and you'll see that in a minute. But here's the challenge. Depending on where you fail, depending on the problem, right? If you rely on a script, we have to download that script and make it available to the task sequence. And there's variables in how you download it. Do you do it beforehand? Different settings you can put, so on. But there's at least the chance that you don't have that script downloaded yet. If there's a network issue, maybe you can't get that script downloaded. So you get to the troubleshooting section, try to run that script. Script isn't there, so it fails, and you don't get any troubleshooting done. No logs captured, right? So it's actually better, in my mind, to actually spell this out, what you want it to do, so it's handled within the task sequence itself. All right. Now, so take a mental snapshot of this, because I'm going to call out a couple of things, right? So we've talked about this is the manual way to do it. How does MDT actually do it, right? So the way that I created this is just simply going into my task sequence and saying create task sequence for MDT and choosing this and walking through this wizard. And it results in an MDT driven task sequence, very similar very similar in concept and process to using this wizard to go create the task sequence using the inbuilt config manager things. The inbuilt config manager create task sequence wizard will create one that looks similar to this, right? May not be exactly this, but it'll look very similar to this. Very, very simple, straightforward, plain Jane. The MDT one will create something that looks like this. Now, let me look at the difference. So let me preface the comments that I'm about to make by saying this very clearly. MDT is a fantastic tool. It brings some amazing things to imaging that are not as easy to implement outside of MDT. MDT does the work for you. Love MDT, great tool. Here's the only challenge that I have with MDT. I see so many people use it without really understanding what they're doing, why they're doing certain things. And to me, that's a risk, right? So look at this sequence, right? And one of the first things when I see people using MDT that I do is pop up the sequence and I ask the question, hey, what is this actually doing, right? And I ask them, can you walk me through this and tell me what this task sequence is actually doing? And if they can walk me through it and explain all along the way what the task sequence is doing, then thumbs up, not a problem. If they can't, then I just encourage them to take a look at it and say, look, if you're relying on this for imaging, MDT is great. It works very well all across so many environments. But if you're relying on MDT for imaging and you are then going to inject some customizations on it and you don't know how this works, then that's a risk, right? So I encourage people to go back and at least for their own learning purposes, build a task sequence by hand or go through this by hand and see what it's doing, and that is going to help them in a number of ways, not the least of which is educate on how these task sequences work, right? Which is very important to doing any kind of customization. So all that said, love MDT, does some really cool things. Let me scroll down to the bottom. Here is where MDT provides the same kind of error handling. We just, in MDT, do it a little bit more granular. There's some effort to protect the state store if you're doing local user state and so on, and then the copy logs, and you see that all these are handled by scripts and different things, right? So in concept, really similar to what was just done in a totally custom section, right? So those are the two differences. All right, so let me move this back out again and move on. So that's the bulk of the discussion. I'm going to hit another couple of things really quickly as we go through and kind of wrap this up. All right, so another thing that I'll hear sometimes is, how do you actually track task sequence progress while the task sequence is running, right? Well, there's actually a few ways, and this shouldn't be up yet, but regardless, you'll see that in a minute. One is, if you've ever watched imaging, which hopefully you have, you've seen on the imaging system itself, there's a nice little progress bar that shows you how the task sequence progress is happening, right? So that's a really nice way just to, on the fly, watch each system that you're imaging. Now, you might have phases in which you can't necessarily watch imaging. Keep that in mind. If in a minute you have the PE phase. It's not as seamless to be able to connect to the machine and watch it image there. Once you get into the Windows phase, at a certain point you can RDP to the machine and see things, right? So there's ways to access the system remotely and watch what's happening on it, right? So just using the wizard or the progress bar. There's also some really nice reports in ConfigMgr that will help you with that. So if you go up to Assets and Compliance, Monitoring. You go to Monitoring and look at your task sequence progress reports. There's several here that you can use. Now, I don't have any task sequences in progress right now, so kind of hard to show you live data, but you can see progress of task sequences for OSD. And it's pretty close to real-time representation. You'll actually see when you choose a system, okay, the system's gotten to step 31 and step 42, or erred on step 28, or whatever it is, in a kind of a chart kind of table representation. So that's actually pretty good and shows what you generally will want to see. It's not as pretty maybe as a progress bar, but we do have other things like progress of all running task sequences and different things, progress of a single task sequence, whatever. So that's reporting. In addition, so this is something that is an MDT. I've never used it in ConfigMgr. I'm sure that you could figure out a way to pull something like this over, but it's kind of beyond the discussion here. I just want to show it to you. So in MDT, this is one of those cool things that MDT adds that is not as, it's not represented the same way in ConfigMgr. Okay, come on. There. So there's the deployment workbench, which is the MDT main console. And if you go into that console and go to properties here on your deployment shares, there, and click on monitoring, you'll notice there's an option to enable monitoring. You need to turn that on. Once you enable monitoring, then you'll be able to see real-time or very close to real-time progress on your task sequence execution. So let me pull that out. So what it will show is this will be a list of your task sequences running, how far along the way they are, what percentage, well, I know it's small here, what percentage along the way they are. But then if you open one, you'll actually see a progress bar, how far along graphically the task sequence goes, right? So I just show you that to show MDT does have some cool things. This is available as an additional progress option for you to consider. Again, I've not used anything. I'm not trying to leverage this with ConfigMgr. I don't even know if you can. But since MDT can do it, MDT might be an interesting approach if that kind of thing is really needed. So in terms of tracking progress in PE, so I talked about over here, live on the imaging system, you can certainly RDP into a system at a certain point once it gets into the running OS. You can also do it in PE. I won't really go into it here except to point you back to the session we did, part 19, where I demonstrate the Dart integration and how you can actually, through Dart, see inside PE the progress and see the progress bar even there, right? So you can get visual insight into it. Even create a dashboard perhaps of sorts where you have little small RDP windows and you see all the taskbars and go in. That would be very conceptually possible, right? So that's as much as I'll say about that, except to say if you want to know more, go back to part 19. And then the last thing I'll say, just in the spirit of logging. So whenever we talk about task sequence logging, bulk of the time is spent by talking about the smsts.log, and that's certainly a valid thing to do. However, there are other logs that are very relevant in the process, such as these, and there's more, right? There's the CBS log that records driver injection and Windows update setup and a number of different things in the setup process. These setup errors and so on. Windows update log for the software update deployment portions and so on, right? So don't ignore these. The SMSTS log will be very relevant to help you figure out what you might want to look at, where the problem's happening, whatever. But these are supportive logs, and again, there's others that you can leverage at the same time. All right, so that's it. So that's the logging discussion, talking about troubleshooting, how you can set that up and the different levels, and didn't dig into the logs. That wasn't really the point. It was more to go into the kinds of things that you can do to help yourself. And so we'll wrap up the session here, and one more session to go, and we'll do that. See you next time on it.